Good evening, my dear 11th standard warriors. Welcome to the JEE 2027 class 11th basics of physics, where we are going to talk about all the important elements of a graph regarding the slopes and derivatives. If you have not yet started calculus, this is the right lecture for you. Or even if you have started calculus and maybe you are breaking your head about the concept of slopes and derivatives, this lecture will clear all your foundations so that you can start applying these things in your physics or maybe even in chemistry. Okay, and derivatives and slopes is a very important part in in general science, because you will see you will use it at many different places. All right, so this is a very important chapter, very important, I would say, a topic. It's not there in any physics textbook because they assume that you would have studied this in mathematics. So if you ask me which chapter number is this, it's no chapter number, but in every coaching we do it at the start of the academic year before you start the usual chapter 1 2 3, right? So don't worry, Abhijit, it will start. And ninth, you are in ninth, don't worry. You have a lot of time and we'll be starting the first chapter very soon, right? Hi Siva, hi Vignesh, hi Azad, welcome Tharuna, good evening. Hi Abhijit, uh, hi Chinata Pandu. Wow, nice to see. Very nice names you guys have. Hi Hema. Oh, welcome Hema, welcome Vaishali. Good evening, good evening. So let's begin with the class. And those of you who do not know me, this is your Captain Shreyas. You can call me Capto or Captain. And I have been teaching, guiding for more than 13 years. And I enjoy physics. I love teaching. And best part is that I like mentoring. And when I have mentored, by the way, thousands of students into IITs itself and guided countless students into different colleges and whatever their dreams and ambitions are. So it gives me that immense joy and pleasure and satisfaction when you guys come back and tell me, I got a seat here, I'm doing this, I'm pursuing that. And sir, you know what, whatever you taught that day, it is useful now here in this particular thing. So that is why you should come over here. Enjoy, learn, have fun, and crack the competitive exams, right? So that's about me. Quickly smash the like button in case you have forgotten, just a quick reminder. And yeah, stay subscribed so that you do not miss any of the classes, right? And really, I hope that very soon you will be on the leaderboard next year, for the next to next year rather, for your juniors who are probably in the 10th standard. I want all your faces over here right now. You are just names in the chat box or in the comment section. So very soon you might be, like Daksh was with us for 2 years, 3 years, and Prakhar and Panini and Anubhav, Ketan, or some of them are also toppers in their respective CT entrance examinations. Daksh also cleared some of the Olympiads and also got full marks in mathematics and JEE Advanced. Many of them that you see have done exceptionally well in Olympiads as well. So, they say that when you prepare for JEE exam or you're preparing for the tough examinations, you automatically end up clearing the medium and the easy ones. So that is what, we see year over year, right? So with this, let's start. And what is your opinion about dual degree? It is a good uh, uh, it is a good option, Azad, provided you like the subject. And you, if you sometimes you don't have an option, that's why you take up dual degree, because the cutoffs are lower. So you have to spend one extra year in a specialization which might not be needed if you are not interested. So that might be a wastage. But if you are very sure I want the IIT degree, then it's fine. All right. Yes, definitely, Hasbida. Right. Yes, Roar series is definitely good to watch, Abhijit. Definitely. But this is the live version that you are getting, and improved content, new content, fresh, and with the actual participants who will be competing with you in JEE 2027, right? Okay. So to talk about these graphs and slopes and derivatives, let's understand one thing. See, there are many things in physics which depend on something called as the slope concept or derivative concept. All right. For example, when I tell you that uh, how many, how many, how many kilometers do you cover, do you, do you cover every hour, every hour? What I'm essentially asking is every hour. What I'm essentially asking is basically what what is the rate of the displacement? What is the rate of the displacement? What is the rate of the displacement? And whenever this word rate comes, it is per unit time usually. So whenever this word rate comes, all right, in physics, you will see what is the rate of doing this, what is the rate of doing work, what is the rate of doing this displacement, what is the rate of changing this velocity. Usually this comes with in the context of per unit time, or every second or every hour or every minute, how much of that physical quantity are you doing. So you will see many physical quantities which have this word rate as a part of it. All right, so what is the rate of displacement is how many kilometers are you covering per every hour. Similarly, you might have also heard about what is the rate of doing work. What is your rate of doing, what is the rate of doing work? It basically means how much work are you doing per unit time. That is the question at hand. Sometimes the question could be also what is the rate of change of momentum. You will see later on the rate of change of momentum is force. What is the rate of the change of the momentum? What is the rate of change of the momentum? Which means what? On the top, you should have how much is your change in the momentum, how much is your change in the momentum, and how much time you took for it. So rate of change of momentum is how much is the change per unit time. Rate of doing work is work upon time. Rate of doing the displacement is displacement by time. That is the context of that word rate in physics. I hope this is clear, and you can see very clearly it is used in different places in physics, and you will see it in chemistry as well. Now, when you want to calculate this rate, there are usually two approaches for this. One is the graphical approach, completely via graph and geometry. And the second one is a purely formula approach, which is also analytical method. Both are right in their own places, but usually you will be using the non-graphical, meaning the formula analytical approach, because graph-based questions are going to be there, but it's not so vast. I mean, it's not going to be so clear in graphs. Sometimes maybe the graph that you have drawn is not so obvious or so clear, or maybe there are some mistakes in it. So that's why usually we prefer the analytical method, but we are also going to learn graphical method because there are definitely questions in IIT JEE advanced as well as mains on the graphs part. So what's the difference in that graph and analytical? Will come to it, but before that, let me tell you what is the way in which you represent in a graph versus you write it in mathematical formulas or equations. Say for example, I put over here a graph like this. This is usually x-axis, which is your input, you say, and this is your output. You tell me x, I'll tell you what y is. You tell me y, I can tell you x also. That's fine. Say for example, I tell you, listen, my y, my y value is basically x cube plus 2. X cube plus 2. Chumma, I have told something. Meaning, you tell me the value of x. That means you input the value of x. I will give you the output. I will give you the output. For example, if I put the value of x as 0, 0 cube is 0, 0 plus 2 is 2. So the output will be 2. If I give the input as 1, you can clearly see 1 cube is 1, 1 plus 2 is nothing but 3. If I put the value of x as 2, 2 cube is 8, 8 plus 2 is 10. So if I put the value of 2, I'll get it as 10. So on and so forth. You can keep putting the values and you will keep getting the outputs. So if I start plotting these points, for example, on the graph, so when the input is 0, The output is 2. So already I have some value over here. When the input is 1, that means the x value is 1. The output is 3. So maybe somewhere over here. So when the input is 2, then the output is suddenly going to 10. Okay. And maybe later on it might go over here. So if I join all these points, maybe I get a curve like this. So this is the curve which represents that equation. So this is that curve, or basically that particular graph that represents the equation, represents that particular equation. So this is analytical, pure formula based, numbers based, whatever. This is visual, this is graphical. Every formula can be converted into graphical. You can also do graph to formula, but that is more tedious. Everybody fine till this point? Give me a thumbs up. Yes, the Sigma batch completes the entire syllabus, PG. Definitely. I mean, why else would we have a batch if we don't complete the syllabus, right? So this input output is also sometimes called as a function. What is it called? A function. So usually you will see in maths, you write it like this. Y is f of x. This f over here is a function. What is this meaning of function? It processes whatever you give as the input, and it processes and gives the output. Like in a mixer, you add carrots, you add maybe, I don't know, some masala, you add some, I don't know, some other thing, maybe some cucumber, and you process it. That means you turn on those knobs, you grind it, and you get some juice. So same way, these are the ingredients. Basically, that is your input. This is the processor, like your mixer, your grinder, whatever, okay, your food processor. And it gives me the output. It could be your juice, it could be your soup, it could be something else, it's some powder, whatever it is. So this is your output. And any such relationship can be shown graphically, maybe like this. This is the curve which represents that particular function. And in physics also, most of the times you will have some functions. It could represent velocity. It could tell me the displacement. It could tell me the momentum. It could tell me the pressure. It could tell me the volume. It could tell me the rate of flow of some fluid. Anything. So you tell me at what time am I looking at it, and it tells me what is the value at that instant. So many times you use functions in physics or chemistry. Everyone fine till this point? No, today we are not going to do integration, only derivatives and slope concept. Everybody give me a thumbs up. Did you understand what a function is and why we need it in physics? Okay. So there are many cases where I will tell you this is the place, this is the time, and at that time what is the pressure, what is the force, what is the momentum, what is the velocity. So all that can be either shown in graph or in analytical form, in formula form. Okay, like this particular function over here. This was an example. This was just an example of the same. Okay, this was put in table. Here I have just put it in a general form. Right. Yes, electrostatics will continue, by my dear. It will be at 8 o'clock. Okay, 8 o'clock is for 12th standard, 6 o'clock is for 11th standard syllabus. Okay, now that you understand this much, say for example, I tell you, hey, listen, the velocity is a function of time. And I tell you, listen, the velocity looks like this. V is equal to 5 by t. V is equal to basically 5 by t. Chumma, I have put a function. How will that graph look like if you start thinking about it? Well, let me put a table form. So that will be very, very clear. So this x is your input. This x is your input. This y is basically your output. So Chuma, I'll take some values. Let's say 0. If I put x as 0, this time becomes infinitely large. Basically, I can't put 0. I can put close to 0. So tending to 0, it becomes infinitely large, right? Because if this denominator is very small, the whole ratio becomes huge. If I put the value as 1, time as 1, what is the value that I'm getting? I'm getting the output as 5. If I put the value as 2, time as 2, 5 by 2 is nothing but 2.5. Interesting. If I put a very large number, maybe infinitely large number, if this becomes very large, then this ratio becomes very small. So if I make this number input very large, the output becomes very small. I can also put some negative values and check it what is happening. So if I put -1, you can see time is -1. So this will become basically -5. Oh, interesting. So it can go on the negative side also, on the positive side also. Let's stick to positive values for now. There is no harm. Okay. So if you plot this particular graph, how will it look like, my dear students? If you plot this graph, when it is close to 0, x is close to 0, it is infinitely large. When x is very large, then the output is very small. So the graph will look like this. The graph will look like this. You can see it is becoming very large when x is very small, and when x is very large, the y value is becoming very small. Are you able to see that? This is the graphical way of representing it. Is that right, everyone? Very good. Now that you understand, okay, what is that graphical way and what is the analytical way, let's talk about this concept of slope. What is this slope? What is the meaning of the word slope? Okay, and that is very useful in determining something called as the rate. See, slope is basically the steepness of a curve, or basically a line, the steepness of a curve or a line. And let's say for example, I give you certain examples like this over here, then like this. Second. So say for example, this was our x-axis. It's very important. Okay, so whatever that gray dotted line is, that is basically our x-axis or horizontal axis, whatever you want to call it, horizontal axis. When a line or a curve is going upwards, then it is said to be positive slope. When the line is neither going up nor going down, it's just running flat to the horizontal axis, it's said to have zero slope. So this line over here has basically a zero slope. It's neither going up nor going down. So the slope, the steepness is zero. But when you are coming down in a curve or a line, then it is said to be negative slope. But how negative or how positive depends on the steepness. As you can see, you are climbing up. Always go from left to right, guys. Here, imagine a vehicle. It has to climb up like crazy. Here, it does not have to climb up that crazily. So, always, whenever the steepness is very high, the magnitude of the slope is very high. So, this is heavily positive slope. This is more positive, or I can just put it over here like this. So this is more positive slope. This is more positive slope. Here, this is positive, but not as much. So less positive slope. Not as much as this one, but it is slightly positive. This one over here is going down. So definitely it is negative, but it is not as negative as this guy. So less negative slope. But this one is basically more negative slope. This is basically more negative slope because it is going down really fast. Always imagine some imaginary object going across this. So just imagine a vehicle. If you imagine a vehicle, it becomes very easy. If you imagine a vehicle, okay, so then it is very easy. Okay, so it is very easy for you to visualize what is more positive or less positive, etc. Okay, so just imagine like this. Here, imagine that same vehicle going down. Very easy for that vehicle to go down. But here, it will go down even faster, more negative slope. Okay, more negative slope. Is this clear, my dear students? This cycle going up or down? Yeah, everyone give me a thumbs up. The 12th will be always at 12 o'clock, 8 o'clock. I have already mentioned this, Ramya, during the launch, during the reveal, and even during the class. Yeah, so please note that. So I will show that to you on our channel also. See, guys. Yeah, see, 8 o'clock is always class 12th, right? Class 12th always at 8 o'clock. We had already completed part 1 of the chapter, or 2 days back, right? So we'll continue. The next lecture will be tomorrow. All right. All right, perfect, perfect. And those of you who are not aware, last time we had conducted the first class of basics of kinematics, and kudos to all the students who put up the comments over here. Very good for your answer, homework answer. By the way, the PDF is here, the answer, everything was here. So very good, guys. Many of you solved the homework. Very good, Arul, GA aspirant, Aruneshwara, Ankan. Yes, very good, Sanjay, Katur Palvai, BBC. So many of you have given the right answer. Very good. Dheeraj, Pratik, Gopal, Praveen, user is Natik, Rajesh, YSRTC, Durga Rao. Very good. Keep it up, guys, like this only. So after every class, you are going to get a homework. You need to put it up in the comment section, right? The answer for it. Yeah. Awesome. Now, let's go ahead. Okay, 1 second. One second. I get this slide. Now that you understand what is the meaning of positive and negative slope, let's see how to calculate the value of the slope. Okay, sir, it is positive or negative. That much I understood, sir. But how do I know how much positive and how much negative? So the manner in which you calculate that is as follows. The value of the slope. The value of the slope is always, you will see, in a very layman, crude terms. Think like this. When I'm traveling this much, how much high I am going up or how much down I am going, that defines my slope. If I travel 1 meter, if I go up a lot, my slope is more. If I travel 1 meter, I don't go anything, then my slope is 0. So how much am I changing in the y-axis if I travel in the x-axis? What is x-axis? I just told you just some time back. X-axis is input. What is y-axis? It is basically your output. So how much will the output change if I change the input? Makes sense. Imagine a mixer. In that, instead of adding 1 carrot, I add 2 carrots. How will the juice taste change? So that was the output. Ingredients have changed. So how will the taste change? So input making some changes there, the result will also change. If you study well, your result will be better. If you don't study well, your result will be bad. So my dear students, so slope in very layman terms is basically the change in the output, upon the change in the input. Now, what is the word which is used for change? There is a word or the symbol which you use for change. So change is also represented, instead of writing CHANGE every time, you just put delta. The symbol is delta. So whenever you use this delta symbol, it means change in that quantity. So for example, if I say delta Pandu, that means how much did Pandu change? Pandu was very good. Now he is not that good. He is very mischievous. So there is a change in Pandu. So that is the meaning of the word delta or the symbol delta. So can I say then it is nothing but delta over here only I can put, this is nothing but delta of output upon delta of input, my dear students. Delta of output upon delta of input, my dear students. Yes, perfect. But what is output usually? Yes, it is the y-axis. So I can say it is nothing but delta y by delta x. So this is the formal way of writing it. This was very crude way. In a very layman terms, I can explain this like this. But in a mathematical pure sense, you write it delta y because output is usually the y-axis. input is usually your x-axis. So change in y upon change in x is basically the slope. So let's try and calculate the slope in certain examples. All right. So let's try to calculate the slope in certain examples. Say for example, over here, okay. So let me just take up few examples out here so that we are very, very clear. Okay. Everywhere standard, guys. This is x, this is y, this is x, this is y, this is x, this is y. Okay. All right. This is x, this is y. So let me just draw some lines everywhere. Maybe I will just draw over here, then I will just draw over here, then maybe I will just draw over here like this, and maybe I'll just draw over here like this. Okay. Chuma, I have taken some examples over here. So let us just start marking the values. Let's say this is -2, and let's say this is 6. Let's say this is obviously 0. Let's say this is 4. Let's say this is 10. Let's say this is 0. Let's say this is 2. Okay. Let's say again this is 0. Let's say this is -3. Let's say this is 9. This is 0, of course. Let's say this is -2. Let's say this is 4. And let's say this is -10. Okay. Chuma, I have taken some random values and I want to find out the slope in every case. Okay. Let's try this out. Starting off with the first one. Here, the value of slope. Here, the value of slope, how much will it be? Okay, let me just reduce the pen thickness. Okay, what is the value of our slope? Change in y upon change in x. What is the change in y upon the change in x? Here, if you see, from this point to this point, the y has changed this much. So the change will be always final minus initial, by the way. So if you are also wondering, change always will be the final value minus the initial value, or the new value minus the old value, whichever you want to use. Okay, final minus initial or new minus old. That is the formula for the word change. So here, as you can see, my dear students, the new value of y is 6. The old value of y was -2. So 6 minus -2 upon the change in x. This is the new value of x, which is 4. The old value, old is this side, new is always this side, okay, in x-axis. So it will be 4 minus 0. So how much will it be, my dear students? 6 minus -2 is basically 6 plus 2, which is basically 8, divided by 4, which is nothing but +2. It is expected that the slope would be positive. Yes. No, slope is not a vector. Yeah. My mother tongue, I mean, there are multiple mother tongues, because the thing is, what do I say, man? I was born in Tamil Nadu, in Salem, right? So that way I should be a Tamilian. But I settled down in Karnataka. I was raised up in Maharashtra, but I have my ancestors in Andhra. So it's a very mixed breed. Yeah. Okay. Going up to the next problem, my dear students, here it is. What is the slope? What is the slope over here? Okay. Well, change in the y, meaning final value of y, as you can see, is 0. This is old, this is new. From here to here, the graph always goes from left side to the right side. So this is the newer value, which is nothing but 0 minus the older value. Older value was basically 10. Older value was basically 10 upon change in x. This is the new value in x. This is the old value of x, which is 0. So it will be -10 by 2, which is basically -5. Everybody clear till this point how to find the slope? Everyone? Yeah? Right. Similarly, let's do the same logic over here. Let's do the same logic over here in this particular case. So what is the slope? What is the new value of y? It went from here to here. This is the y coordinate. How much is it? 0. Minus. What is the old value? It is basically -3. Can you see that? -3 is the older value. Old to new. Then x new value is 9. The old value was 0, or the initial value was 0. Perfect. So this will be nothing but 3 by 9, which is nothing but 1 by 3, which is also positive, which is because it is going up. Let's do it in this scenario. What is the value of slope, my dear students? Again, what you need to do, old value and new value. Just see what is the new value. It is basically negative 10. So final, yeah, many mother tongues you can say. Yep. I hope this is clear. Everyone, awesome. So in order to find out the slope, we always do the changes in the y, change in the y upon change in x, which is also the y final minus the y initial upon the x final minus the x initial. X initial. Okay, this is good, sir. I understood this much. But sir, I have an issue. What is that issue? Sir, imagine the graph, sir, is not a straight line, sir. What if the graph itself is maybe that graph itself is some curve like this? See, when you have straight lines, it is having same steepness, same steepness, same steepness, same steepness. So the slope is constant. But when you have a curve, the slope is not constant because sometimes it is more steep, then less steep, then more steep. So the steepness changes the moment there is a curve. But maybe I don't need instantaneous values. Maybe the graph is somewhat like this. It's like a curve. And I want to find out what is average slope in a certain region. And maybe that region is also given to you. Maybe from here to here, sir, I want to find out what is the average slope. So I'll mention this point over here. For a curve, the slope is not constant, is not constant. So usually you might use the word called as average slope. So average slope. So average slope is always between 2 points. Average slope of a curve is always between 2 points, like over here. Say for example, this is x2, this is x1 coordinate, this is y1, this is y2 coordinate. How do I decide who is 1 and who is 2? Always whatever comes first is 1 initial, and then this comes later on. Always have to go like this, left to right. So this is later on, this is final, this is initial. So 2 represents final, 1 represents initial. So the average slope in such a case will be as simple as y2 coordinate minus y1 coordinate upon x2 coordinate minus x1 coordinate, which is nothing but this difference, y2 minus y1. This is y2, this is y1. So from y2, if you take out y1, what is remaining? Only this much, right? Only this much is remaining. And what is this much? That is basically the change in your y. From x2, if you take out x1, only this much is remaining. That is basically your delta x. So you can also write it as delta y by delta x, which is exactly the same formula which you have seen before also, but it is for an average value of the slope. This is the same thing which you have seen here. This was for a straight line. Fair enough. So the average slope is nothing but how much on an overall level, how much did the y change on an overall level when the x changed by this much amount. So I traveled this much. How much did my y change overall? That gives me the average value of the slope. Right. So now let me see if you can answer this particular question. Imagine this particular graph. Imagine this particular graph, which I'm just showing it to you over here. Let's say the graph goes like this. Okay. Let's say this is -3. Let's say this is 3. Let's say this is obviously 0. Let's say this is 7 or maybe 8 or something. And let's say this is maybe 6. Let's say this is 10. Let's say this is 11. Okay, Chumma have put some values. and maybe over here this is 15. Okay, so some random values I have taken of a random curve. Can you tell me, what is the average slope? What is the average slope from x is equal to 3 to x is equal to 6? That is the question. What is the average slope from x is equal to 3 to x is equal to 6? That is the question. So the slope is asked. So let me put it over here. Slope from x is equal to 3 to x is equal to 6. So that will be change in the y upon change in x. Change in y upon change in x. So look at it. You have gone from 3 to 6 over here. As you go to 6, what is the value of y that you are getting? As you go to x is equal to 6, what is the value of y that you are getting? It is basically 8, isn't it? So put final value is 8 of y. What is the original value of y when x was 3? Oh, it was 0. When x was 3, y value was 0. Now go to x2 minus x1. This is x2, this is x1, obviously. So this is x2, this is x1. So that's it. This will be nothing but 8 by 3 is the slope. 8 by 3 is the slope. Very good, Azad. Perfect. All right. Okay. Let's see how many of you can get this. If average value of slope has to be measured from x is equal to 0 till where should it be measured? Or I would put it like this. If the average value of the slope is measured as 0, comma, from x equals to 0 till where should it be measured so that the average slope is 0? So it is starting from x equals to 0. So think about it. X equals to 0 means over here. So from x equals to 0, where should you measure it so that the average value will be 0? So think about it. Slope in general is nothing but change in the y upon change in x. But it is clearly mentioned my slope is 0. If slope is 0, that means what? The numerator delta y should be 0. That means y2 minus y1 should be 0. That means the y2 value should be same as y1 value. That means the final y coordinate should be same as the initial y coordinate. So what was the original y coordinate when x was 0? When x is 0, the y coordinate was -3. The y coordinate was -3. So when is the y coordinate again -3 in this curve? It is very obvious. It is exactly over here when x is equal to 11. Therefore, when x2 is equal to 11, then you will see that the y coordinate is exactly -3. So that is the point. So you will be measuring the average value from here till here. You will see that the y hasn't changed. The y hasn't actually changed. It is still -3. So that is the point till which the average slope is 0. Perfect. Just a random video. No, man. If you put your name like that, it will be very difficult for me to remember. Oh, okay, sir. Now I understood what is the meaning of average slope, sir. Can I use it somewhere? Many places like finding average velocity, average speed, average change in momentum. So all those places you use this concept of average value of the slope. Okay. But now I have a concern because I just told you that in a curve, the slope is not constant. What if I want to measure that exact value of the slope at every instant? So say for example, this is that curve. So this is some curve of y is equal to some function of x. And I am trying to measure instantaneous slope. Okay, what am I trying to measure? I'm trying to measure instantaneous slope. I just know that if I take two far away values like this, which are separated by a decent distance like delta x, then there is a good amount of change in their output, which is represented by your delta y, and what you get is the average value of the slope, which is delta y by delta x. Now, please remember here, delta y and delta x are always finite, are always finite numbers. Basically, they will be measurable. They will be measurable. Even if they are zero, that's okay, but they are always finite values. Why am I suddenly talking about finite? Am I going to talk about infinite? Not exactly infinite. I'll be talking about infinitely small values now. See, remember, if I tell you, say for example, delta x is equal to 7, that's a finite value. Delta x is equal to 0.2, that is also a finite value, you can measure it. Delta x is equal to 0.00005, that is also finite value. Delta y is equal to 0.003700056, this is also finite value. All these are finite values. Okay, all these are finite values, but there are some values which can't be measured, but there is a meaning in it, there is some sense in it. It's not represented by a number, it is having some vague value, but I know it is not this, but it is close to this. So that is where that infinitely small, infinitely large concepts come. Yeah. So imagine I now don't want to measure average slope. I want to measure instantaneous slope. When I say instant means what? At that moment, right? So when you hear that word instant, 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 instant coffee, what does that mean? It is at that moment, at that moment, or at that value, or at this place exactly. I'm not interested in a range, but at that value. So what I need to do then, I cannot have a big change in the input. Imagine in that mixer grinder example where I was trying to make a carrot juice with cucumber or tomatoes or whatever. If instead of 1 carrot, I add 3 carrots, how will the juice taste? So I was measuring how my output was changing based on how my ingredients were changing. But imagine instead of adding 1 carrot, I add slightly more than a carrot, a very small tinge of it. So there is a very minute change in the taste. So I need to change my x very minutely, very minutely. So the y will change very minutely, but it will change at that small addition. It's very, I would say it's not so noticeable, but there is definitely some small minute change, isn't it? So my dear students, what I need to do is I need to ensure that my x has come very close. So as you can see over here, my delta x is going to reduce. Because of this, there is a consequence. As a consequence, even the y values will come closer. So I will say that these two values are coming closer. So delta y is reducing as a consequence. Delta y is basically reducing as a consequence of it. I am moving in this process. I am moving in this process from an average value, from an average value to a more instantaneous value, to a more instantaneous value. This happens as delta becomes closer and closer, smaller and smaller, delta, which is a finite value, becomes infinitely small, and such a small change is then called as d. That small change is then called as d. Now understand the difference. Delta has a number, has a value, can be measured, but d can't be measured. For example, I can never ever say dx, small change in x, is 0.00000053. No, this is not valid. You cannot put a number with it. Can I write, sir, dx is equal to 0 point, sir, infinite zeros and then 1? This is also not allowed. No, this is still a representation. You still can't put a number with it. You can't even put it as like infinite zeros and then 1. That is also not allowed. So this basically, dx is definitely not 0, but close to 0, close to the number 0. It's very, very small. It's an infinitely small value. I can't tell how small it is, but it is closest number to 0, but I can't put a number on it. I just can't put a price on it. They say, right? My love towards students can't be judged with a price tag. I mean, it's there. You can't see it. You can't put a number, but you can feel it. Is that right? So it's close to 0. So therefore, it is often represented, dx is nothing but delta x is close to 0, but it is not equal to 0. So dx is a very small number, but it is not 0, and there is no number that you can put on it. Did you understand what is the meaning of that symbol d? And how is it different from the word or that symbol delta? Give me a thumbs up in the chat box right away, right now. Everyone. Nobody will try to find the value also. Abhijit, it is not needed also, because that concept is enough. So when I make this delta x very, very small, when I make this delta x very, very small, tending to 0, and eventually I bring them really close. So let me just get rid of this. So I have got it very, very close. It's like they are two neighbors. They are so close that they are two neighbors. Okay. So that difference which is now there between the y-axis, that is dy. The difference which is now there between the 2 points over here, that is basically dx. That is basically dx. And then the slope that you will be measuring, that will be instantaneous slope. That will be instantaneous slope. And that would be dy by dx. That would be dy by dx. Small change in y upon small change in x. Now I'll tell you what is the most beautiful thing about this formula. I intend to find what is the slope, but just now I told you nobody can tell you the value of dx. You can't put a number on it. It is not equal to. Okay. So that means, do I know the numerator? Put an answer in the chat box. Do I know the answer of the numerator? Come on, think about it. Yeah. Come on, guys, don't flirt out there. Focus on the class. And do I know the value of dx? Do I know the value of dy? Think about it. Do I know the numerator? Do I know the denominator? No, I don't know the numerator. I don't know the denominator. That's the beauty of this. But yet, in the next couple of steps, I will tell you what is the value of dy by dx. I neither know the numerator, nor do I know the denominator, because they are both infinitely small values who cannot be associated with any numerical value. They are just tending towards something. But I can find the ratio. I will be able to figure out what is the value of dy by dx. So that is the beauty of derivatives. So this is also called as, by the way, this is also called as the process of differentiation. So this is also called as derivative derivative of that variable y with respect to that variable x. You can use the word derivative or the word differentiation. 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 Differentiation of y with respect to x. You can also call it as the rate of change or the rate of change of y with respect to that variable x. How much is y changing with x? Differentiation, derivative, rate of change, instantaneous slope, or just dy by dx. All of them mean the same thing. So if tomorrow I tell you what is the rate of change of pressure with respect to temperature, it means I'm asking you dp by dt. If I ask you what is the rate of change of momentum, okay, now when with respect to is not there, it is automatically understood. I'm asking you rate of change of momentum with respect to time. So time is automatically there when there is no other phrase mentioned. Okay, so just rate of change of momentum means with respect to time only. If it is mentioned rate of change of momentum with respect to displacement, then I will put dp by ds. Then I'll put dp by ds. So that is how this word plays. Okay, everybody understood what is the meaning of rate of change or instantaneous slope or derivative or differentiation? It is just a small change in the input which causes a small change in the output. So I'm noticing that ratio of those changes, output by input changes. Is that right? Everyone till this point? Very good, very good, excellent day. Awesome, great, great. Some of you need that slap, I feel, in the chat box to get banned or get timed out, because you guys have come here to do time pass. Yeah. Okay. Fine, sir. I understood here, but please tell me the value, sir. It is very simple. I'll tell you. Just focus on this part. Just let's look at those two immediate neighbors. That that curve will look like a line almost. Yeah. That curve which is there. That curve which is there. 1 point here, 1 point here will almost be a straight line. The distance between these 2 points, like this here, let me put it here, guys. Second, sorry, this was basically dy, is that right? And this was basically your dx, is that right? This was dy, this was dx. How about constructing a triangle? How about constructing a triangle like this, right angle triangle? Okay, a beautiful right angled triangle. So the height of this triangle will be dy and the base of this triangle will be dx. Okay, height of the triangle will be dy, base will be dx. How about checking out this angle over here? How much is this angle? Let's say I will call it as theta. And now just leave it like that one. That particular angle is theta. Okay. What will happen if I just extend that hypotenuse here and here? If I extend that hypotenuse here and here, in fact, that will nothing but become the tangent to the curve. It will be a tangent to the curve. So if I just consider that particular line over here, that is basically the tangent to the curve, isn't it? And whatever angle that the tangent makes with the horizontal, which is basically theta, will also be the angle which the tangent makes with the x-axis. Whatever, okay, this thing, let me just get rid of it. Let me put that curve here. Whatever the tangent makes with x-axis with also the angle which the tangent makes with dx over here. So can I mark this particular angle? Can I mark this particular angle also as theta, my dear students? Can I mark this particular angle also theta, my dear students? Everyone? Yep. Everyone with me on this? Oh, so what is your point, sir? The point is, check it out, dy and dx, what are they? In that small little triangle, that is basically opposite side to theta, and dx is basically the adjacent side to theta. And what is opposite by adjacent in a right angle triangle? It is nothing but the tangent ratio, or basically tan theta. So basically that instantaneous slope is tan theta. That's it. We have got the answer to it. We have found the value of the ratio, which is tan theta. Tan theta is the answer, where theta is basically the angle made by the tangent with horizontal axis, with horizontal axis, with horizontal axis. That is the answer. Geometrically, this is the answer. It is basically the value of the tan theta, where theta is the angle made by the tangent drawn to the curve at that particular point. Let me demonstrate this to you with an example. You will be astonished to see this. Imagine I have this x and y axis again, and let's say some random curve I'm drawing, chumma. Okay, some random curve. And let's say I choose a point somewhere over here. And let's say if I draw a tangent there, ayyo. If I draw a tangent there, then that particular tangent is, example, making 60 degrees with the horizontal axis. Let's say this particular point is x is equal to 7. If I ask you what is the instantaneous slope at x is equal to 7, then the answer will be tan of theta, but theta where x is equal to 7. If you draw the tangent, the theta over there is making how much angle? 60 degrees. So it will be basically tan of 60. What is tan 60? It is basically root 3. Root 3 is basically 1.73. That is the answer. So the slope of this line is 1.73. That's it. Done and dusted. Best part, I don't know dy, I don't know dx, but I know dy by dx, which is tan theta. Isn't this marvelous? If you take some other point, maybe, let's say some other point, maybe somebody has taken this particular point over here, okay, or maybe somebody has taken this particular point over here, okay, and if you draw, let's say this is maybe x is equal to 2. At this particular point I want to find the slope. What is the instantaneous slope at x is equal to 2? At x is equal to 2, what will you do? Again you will draw a tangent, but because it is going down, the answer will be negative. Just keep that in mind. For now I'll just show this particular angle. Over here. Maybe it is 30 degrees. Chumma, I have put some number over here. Okay, or I can also put, let's say, 37 degrees. 37 degrees is a standard value which you should remember. Okay, in case you are not aware, I will tell you the value of tan 37 also. So that case, the slope will be negative. Why negative? Because it is going down. So negative tan 37. Why is it negative? Because it is going down. When it is going up, it is positive. When it is coming down, it is negative. So tan 37, the value is 3/4. It's a standard value. When you learn mathematics, trigonometric ratios, etc., you will learn these special numbers also. Okay, you will learn these special numbers also. All right. Katusha, I will tell you, there are links in the description box which you can check out, and you can find out the address. Just visit the center by booking an appointment using one of these links. Okay, just hold on for 1 second. I'll just show it to you. So this is minus 3 by 4, which is nothing but negative 0.75. That is how you figure out the slope of this particular line. Is this absolutely clear? Somebody will be like, sir, can you tell me what is the slope of this point over here? Like this. I want the answer in the chat box immediately, guys. Let's say this is x is equal to 10. What will be the slope? What will be the slope at x is equal to 10? Think about it and answer. What will be the slope at x is equal to 10? If you draw the tangent, it is parallel. So theta is basically 0. So tan theta will be also 0, because tan of 0 degrees is basically 0. So hence the slope will also be 0. Okay, at this particular point, if you draw the tangent, it is not meeting only the x-axis, it is making 0 angle with the horizontal. Hence, the slope is 0 over there. So this is the geometrical way of figuring out the slope. Beauty was, you don't know numerator, you don't know denominator, but the ratio is the tan of the theta, where theta is the angle made by the tangent drawn to that particular curve. So some of you are asking, sir, where is the link? Well, for joining the offline center, the links are there in the description box of this video also, as you are watching it. So let me just go back to our video. Say, for example, this particular video, which you are watching right now. Just go down, explore our offline centers, book a visit now. No matter which part of the country you are, you can always go down to the description box, yeah, and you can check out the links. Enter your name, age, your phone number, and which city. So you can see Chennai, there are so many centers: Anna Nagar, Vellacheri, Tambram, Avdi, Perambur, Porur. Okay, and right now we have opened a new center in Bengaluru, and yes, that is in JP Nagar. Yeah, we have opened a new center in Bangalore, which is in JP Nagar. So if you are in Bangalore, please visit the JP Nagar center, and you can inquire about any batches or courses that you might be looking forward for JEE or NEET or whatever. Okay. Otherwise, if you are and wherever you are, you can always also look out for scholarship. Please ask for this IVSAT exam, because you can get up to 90% off on your fees for any batch. Okay, so that's the exam which you need to give over there or even online, and based on your scholarship, you can get your fees reduced. Your discount will be based on the scholarship examination. All right, so please check that out. All right, fine, sir. I love this method, sir, of finding out the slope. I just have to draw a tangent. But how often do you know the graph, and how often is the graph drawing so easy? It is not so easy every single time. So there has to be a different method to find out dy by dx. Do you guys agree with it? So let me put it over here. So keep this in mind. Drawing a graph may not be feasible every time. Sometimes you don't know how the graph is. Sometimes you might get non-standard values of theta. Like for example, theta is 38 degrees or theta is 79 degrees. Then what is the tan value? Then you need log tables, etc. Also, there is human error. In drawing the tangents, in drawing the curves, in drawing the tangents, everything. For example, you give me 2 points, or you give me a series of points. Maybe 1 point is here, 1 point is here, 1 point is here, 1 point is here. Then one person might probably draw it like this. Other person through the same points might draw it like this. So which one is correct? Also, imagine if there is a curve over here and you want to find the tangent. One person might say, this is my tangent. Other person will say, no, no, sir, this is my tangent. There is a small difference in them. It's not so visible to the naked eye. And the angles also may not be standard. So these are the problems which you might encounter when you are drawing graphs. But if you have a graph with a tangent drawn accurately, no denying the fact, this is by far the easiest method. Just like this one, already the tangent was drawn. I mean, no big deal. Just finding the tan of that standard values is one of the by far the easiest method to find out the derivatives or dy by dx. Is that absolutely clear? Yep. Perfect. Yes, Raju, for JEE Advanced concept level teaching, you are already watching these classes. Plus, if you want that extra personalized support, you have the offline batches or the our pro batches are already there for 9th standard, 10th standard, 11th standard, or 12th standard. Okay. So for 9th, 10th, it is foundation courses. For 11th and 12th, it is our pro batches for 2 years or 1 year. Okay. So the links are again there in the description box. Please check it out. Complete JEE Mains plus Advanced. Fine, sir. So what is the way, sir? So the answer comes as follows. See, first of all, let me tell you this. If y is a function of x, then very, very important, then dy by dx, which is also derivative of that function. So instead of y is nothing but f of x. So whatever y is there, I replace with f of x. So this is nothing but called as the derivative or differentiation of that f of x with respect to x. Differentiation of f of x with respect to x. This can be represented as f dash of x. What is it represented as? F dash of x. That is basically the derivative of that function. That is dy by dx. Okay. So that is nothing but dy by dx. This is a pure representation purposes only. All right. So imagine this. Imagine this. I tell you, hey, you don't have to break your head. There are formulas. The derivations for those formulas will be done in your 11th and or 12th standard when you study derivatives in mathematics. Now, I'm a physics teacher. I have to start physics chapters or else I have to wait for the mathematics to go on. And then, by the time the physics will start, it will be too late. So, no coaching, nowhere. We'll start with those derivations of those derivatives. Okay. Or it is not even needed. You have to just understand that okay, at some point in your JEE preparation, somewhere in the middle, you will be doing how these formulas come. So what am I talking about? I'm telling you, you tell me what is that function. You tell me what is that function. I will tell you what the derivative is. Yeah, that's the best part. You tell me what is that function. I will tell you what is the derivative of that function. So on one side, let me put the function. Let me just put the function. And on the other side, I'll just put the derivative of it, meaning f dash of it, meaning the derivative of it, which is basically dy by dx. Okay, which is nothing but, your derivative of that particular function. Derivative of that particular function. So, what is it, guys? Observe carefully. If you have a function which is basically a constant. Think about it. Imagine, I tell you, y is equal to 3. Y is equal to 3 means the graph will be a straight line like this, parallel to the x-axis. It's neither going up nor going down. The tangent drawn is horizontal, so the slope will be 0. So the slope will be 0. So hence the derivative will also be a 0. So any constant function, the derivative is 0. Do you guys understand this concept? Do you guys understand this concept? Yep. Very good. Yes, this class is for JEE, Sumit. These are the basics for JEE 2027 before you start your physics. Yep. Next, if you have a function which is x raised to 3, x raised to minus 7, or x square, or maybe x raised to half, which is basically root of x. In general, any x raised to n, then the derivative of it is that power comes outside into x raised to the power reduces by 1. This derivation for that happens in mathematics. We don't worry about it. We just accept it. You have that trust. Yes, this will be done later on. but this is the formula. So this is the derivative of this. If you have, I'm just going to give you basic derivatives today because I just want you to understand the concept rather than learning these formulas. If you have something like sine of x, then the derivative of that sine of x comes out as cos of x. But if you have cos of x, then the derivative of it comes out as negative sine of x. There is one unique function which is called e raised to x. This is your exponent, Euler number, Euler constant 2.7, okay, approx value. So e raised to x's derivative just comes out as e raised to x only. So the derivative of e raised to x is e raised to x only. And one last function, you will learn logarithms later on. So log of x to the base e. Okay, you will learn logarithms very soon in mathematics. Log of x, log of a number, like you have sine, cos, etc. This is also a new function which you will be learning. It is nothing but 1 by x. Log of x to the base e, which is also natural logarithms, the derivative is 1 by x. These basic derivatives, if you know, most of your job is done. Okay. For now, let's understand the concept, guys. Let's, for a moment, memorize these formulas, take a screenshot if needed. I'll tell you how to use this. That's the thing which you should appreciate. Constant derivative 0, x raised to n's derivative is nx raised to n minus 1, sin x derivative is cos x derivative is minus sin x, e raised to x is e raised to x, log of x to the base e, derivative is 1 by x. Okay, let's take up a question so that you understand it. If I tell you y is equal to x raised to 3 and I ask you find the slope at x is equal to, let's say, 4. Find the slope at x is equal to 4. Let's try to solve the question. Okay, let's try to solve the question. Because the word slope is used, slope means what? Instantaneous slope means what? Dy by dx. But wait a minute. What is y over here? Y over here is itself x raised to 3. Y over here is itself x raised to 3. Okay, so that was my function. Let me recollect our formulas. These were the formulas which I just gave you. Does it fit vaguely in any of these formulas? I think so. It fits here. X raised to n, x raised to 3, where n is basically 3. Okay, so just keeping this in mind, that derivative of x raised to n with respect to x is n into x raised to n minus 1. That was the formula. So what should happen over here? That power will come outside. X's power will be reduced by 1. So it will be 3 minus 1. So it will be 3x square. But that is not the final answer. That is not the final answer. The question says at x equals to 4. Oh, so the slope at x equals to 4 is asked. The slope at x equals to 4 is asked. So put the value of x as the number 4. 3 into 4 square. 4 square is 16. 16 into 3 is basically 48. So 48 is the answer. So what this actually means is that had somebody taken that effort of drawing that graph of this particular y is equal to x cube, that probably would have looked like this. This is that curve y is equal to x cube. And somebody then went to, let's say, this particular point over here, which is x is equal to 4, 1, 2, 3, 4, somewhere over here. And then that person at that particular point, he draws a tangent to that curve. He draws a tangent to that curve and then he measures that particular angle. So if you end up measuring that angle, then this 48 will be exactly tan of that theta. Will be exactly tan of that theta. That is the meaning of it. Understood? What is the meaning of finding the derivative? This is the graphical representation, which is looking very simple. but the problems I just mentioned it to you over here. Not every time you can draw the graph. Errors are there, human mistakes. It's very approximate. So that's why the exact values you can get it directly through the formulas. As simple as that. That is the meaning of the word derivative. Let's take up some more examples so that you get a hang of it. Okay. So get ready for it, my dear students. If I ask you, find dy by dx of let's say y is equal to e raised to x at x is equal to 2. What is your answer? Let's try to do this. Okay. Find dy by dx of y is equal to e raised to x at x equals to 2. Okay. We have to find dy by dx. But what is y over here? It is e raised to x. But I just told you what is the derivative of e raised to x. It is e raised to x only. It is e raised to x only. So perfect. It is just e raised to x. But the question says find dy by dx at x equals to 2. That means substitute the value of x as 2 in the end. Don't substitute in the start. Okay. So the answer is basically e square. Just leave it like that. That's it. Instead of x, I've just put the number 2. That's it. So this is the answer. E into e. E square is the final answer. Got it? Similarly, let's just try to find some derivatives more, guys. Find d by dx of x raised to 6 at x equals to 2. This is one question. Find d by dx of log x to the base e at x equals to 5. This is another question. Next question. Find d by dx of, say for example, just x square at x equals to -3. This is another question. Okay, come on, my dear students, just try to figure out these answers out here. What is the answer for each one of them? These are your 3 numericals. Today, Abhijit, we are just doing the basics, man. We're not doing any tough questions because the toughness will come when you inculcate the physics questions in it. So once we do kinematics, okay, and instantaneous velocity, acceleration, and all those things, that's when you start seeing those tough questions. Today is just like a bridge course. This is more like a bridge course for gapping that things between your 11th standard portions and 10th standard portions, where irrespective of states, BSc, ICC, whatever, so that you guys get that confidence. Okay, so let's do this. So first of all, if you just take the derivative d by dx of x raised to 6, x raised to n formula, so 6 into x raised to 6 minus 1, which is 6 into x raised to 5. Now substitute the value. So d by dx of x raised to 6 at x is equal to 2, meaning put 6 into 2 raised to 5. So 2 raised to 5, guys. 2 square 4, 2 cube 8, 2 raised to 4 16, 2 raised to 5 32, right? So what is the answer? 6 into 32. 6 3s are 18, 180. So 6 2s are 12. So 192. That is the answer. 192 is the answer for this question. Let's try to do this question. So first, if you just do the derivative of log of x to the base e, I just told you the answer, it is 1 by x. But if you just try to find this one by substituting x as 5, so the answer will be 1 by 5. So instead of x, you put 5. That's it. Perfect. So again, this particular question, just try to find the derivative of x cube, my dear students. Just try to find the derivative of x cube. It will be nothing but 3 multiplied by x raised to 3 minus 1, which is basically 3x square. So now you just need to substitute the value of x as basically, oh sorry, this was x square, my bad. I copied down wrong. So sorry guys. This was just x square. So this will become 2 multiplied by x raised to 2 minus 1. So it will be just 2 into x. So it will be just 2 into x. So hence this particular answer will be nothing but 2 multiplied by minus 3, which is minus 6. So minus 6 is the answer for this. Minus 6 is the answer for this. Sarvana, I don't think this is same as row series. You can check out my row series content versus this. It's definitely different. Okay, let's see if you guys can answer this particular question. Okay, x derivative, just the derivative of x, how much will it be? Just try to figure this out. Just try to figure out the derivative of 1 by x. Also try to figure out the derivative of 1 by x cube. Okay, these are your next numericals. Let's see if you can figure this out. Derivative of x, 1 by x and 1 by x cube. Derivative of x, simple. Let's try to figure it. You can rewrite this as the d by dx of x raised to 1. So this is x raised to n formula. So 1 comes outside and the power reduces by 1. So this will be 1 multiplied by x raised to 0. X raised to 0 is 1 only. So the answer is just simply 1. Is that right? The answer is just simple 1. Dx by dx is 1. Okay. Anyways, if you think of it like that, dx by dx, yes, it should be 1. How about this? Whenever things are below, just take it on the top. So this is as good as saying d by dx. This is positive power in the denominator. It becomes negative power in the numerator. So that power comes outside and reduce that power by 1. So it will become minus 1 into x raised to minus 2. So which is minus 1 multiplied by, this is x square. So you can also write it as minus 1 by x square. So that is the answer for this question. Let's do this. This is as good as saying finding d by dx of x raised to negative power 3 when you shift it to the numerator. Always shift to the numerator and then solve. Don't solve it in the denominator because you know x raised to n's derivative, not 1 by x raised to n's derivative. Okay, so that power is negative 3, bring it outside, reduce the power by 1, so minus 3 minus 1. So it will be minus 3 into x raised to minus 4, which is minus 3 into 1 by x raised to 4. So which is minus 3 by x raised to 4. That is how you get it. Yeah, everyone? Yes. Perfecto, perfecto. Amazing, amazing, amazing. Last question on your screen, and here it is. Derivative of root of x. How much is it? Okay, just try to figure this out. Derivative of root of x, how much is it? Just figure it out. Derivative of root of x, how much is it? This is your last question. Come on, guys. How can you rewrite it as? You can write it as d by dx. Root of x is x raised to half, isn't it? So what will happen? That power will just come outside half, and x raised to half, you will have to reduce the power by 1. So this will just become half into x raised to minus half. X raised to minus half is as good as saying x raised to half in the denominator. So this is as good as saying 1 by 2 root of x. That is the answer for this particular derivative. Yes, yes, it is 1 by 2 root x. 2 root x is in the denominator. So I'm going to give you a homework question. Just figure out this answer, okay? So what is 1 by root of x's derivative? That is your homework question, okay? So this is your homework. The answer should be in the comments. The answer should be in the comment section, okay? Not anywhere else. Okay, don't put it on the live chat, put it in the comment section. Just like we showed this time, the last time's answers in the last time's comments, okay? So next lecture, I'll be showing the comment section. So I would love to see your comments in the comment section. Is that right? Very good. Keep it up, guys. So thank you for liking the session. If you have not yet liked, please do that. And if you're not yet subscribed, don't be so late in it. Please do that right now so that you do not miss any of the lecture series which are being conducted on the Vedantu JEE English channel. This was your Captain Shreyas, and stay tuned for more lectures at 6 o'clock for 11th standard, which is JEE 2027, and even 2026 aspirants can watch it if you want to start from the scratch and have backlogs, and 12th standard lecture series at 8 o'clock. Okay, bye bye. Have a great time. All the best.